Shah, and this is my team in Shashank, and our project is distracted driver detection. Recently, number of road accidents have been increasing due to distraction of drivers, and we need to analyze such distractions by using various models like CNN, that is deep learning models, and also mobile net models. And the main objective of our project is to detect driver distraction in real time and also for trained images, and to collect those data for post analysis and to improve the behavior of driver. This chart shows various age groups who has got accidents, and we have used data set from Kaggle, which is State Farm driver distraction data set, and these are the various classes categorized, namely safe driving, texting right, texting phone right, and various 10 other classes. And this chart shows the class distribution in training data, that is various classes are categorized and group and many images are grouped into them. These are the images after training. For example, you can see C not first image, which means the image shows safe driving. And next below image is C1. It belongs to C1 class. C1, that indicates is texting in the phone, texting with the right hand. And this is RGB overview of the images. Next will be further explained by my team.
This is a data processing overview. First we are loading a data set which is taken from a Kaggle, that is the State Farm data set, and we have 10 different classes. So we have taken a class name and the visualization. We are going to extract the class name and visualize the sample images, so that class name will be helpful for in our prediction, taking the class names. The next step, model compilation. We are using a ADAM optimizer to with a learning rate of 0.0 to categorize the model, and we have trained our model using a CNN model, and also we have tested with other models like MobileNet, VGG, and ResNet. And training and monitoring. In this we have used an early stopping if a model gets an if a model is overfitted, then we'll get some error, then it doesn't give accuracy while it's predicting. So we have used an early stopping to get a best validation accuracy. This is our model overview. Before that, I'll show the code. We are importing a certain libraries for to build our model, like an NumPy, Pandas, and TensorFlow, which are used for mainly image pre-processing and building a model. This is a set of a training data set. We are taking it and we are resizing an image to the 100 into 100 width and height, and we are making it a label as categorical mode, and we have splitted a data into validation to validate our model. This is an overview of images that have been loaded. These are the sample data sets of image. This is our actual model view, which is a CNN sequential model. There is a convolution neural network sequential model. We have included 3 convolution layers and 3 max pooling layers, you can see here, and dropout layers and the flatten layers, and we have taken a activation ReLU activation layer and the softmax activation layer. We have chosen ReLU because to decrease to increase the non-linearity of an image, so that we can improve an accuracy. This is an actual overview of how the model is. We are using an early stopping to get an accurate model to overcome an overfitting of a model. We have used a matplotlib to plot and training accuracy and the testing accuracy. these are the two graphs we have which we have obtained a training and validation accuracy, that is a loss. This is the actual model overview. Like after build, we have tested in using a Neutron application. So you can see here we have a convolution layers and the max pooling layers and dropouts to have a better accuracy in a model. And activation layer, Rayleigh activation layer, and at last we are using softmax activation layer. Here we are using a multi-class classification. Since when we get an actual output, the percent of detected class should be equal to 1, so we have used an softmax. It's a graph overview. This is a video which are using it for a testing purpose. Like we have taken a particular video. We have trained the model on a certain set of images. This is an output we are getting, like to indicate what particular action of a person is doing. We have used an OpenCV to read a video capturing image, and we can this for only demo purpose we are taking a pre-recorded video, but we can also implement this in a real time by using a OpenCV video capture. And this code is for a sequential model which we have built using a CNN, and we have also tried a MobileNet model and VGG model which doesn't get much accuracy as this convolution model, neural network model, sequential model. Like this is how we have built a MobileNet model using a pre function. We have got around 96% of accuracy in a MobileNet model and around 19% of accuracy in a convolution model. Like 96% of accuracy. In this model, we have predicting on a particular image that is texting in with his right hand in his right hand and is driving. Basically, he is a distracted person. We have a class level like whether it tells whether he is a safe running. We have got a text is texting on the right hand. We are predicting on whether it is a safe driving, is texting on right hand, talking to cell phone using his right hand, or texting in the left hand, talking to cell phone using his left hand, operating a radio, or drinking, like reaching behind and makeup and talking to a passenger. And to have a better complete model, we have also included two more things in this. This model in this code we have basically implemented that whether if a driver places both of his hands on a steering wheel, the engine will be started automatically. This is a software thing. We can implement this in a hardware so that automation can be done. Whether while driving, if both the hands are on a steering wheel, you can drive at any maximum speed which is indicated in a road limit. And if only one particular hand is there, for demo purpose, we are telling that you can drive at a max speed of 25 km/h, and if no hands are there, the brakes will be applied slowly. It is telling that place your hands on the screen to start the engine. If I place my two hands on the screen, it will gives an you can drive at the max speed. Engine is started and you can drive at the max speed. Like I am placing just one hand, it is showing that you can drive at only a max speed of 25 km/h.
We have also coded to detect one's drowsiness. If the eyes are closed, it detects he is drowsy. If it is not, it displays that he is ready to or fit to drive. See, it shows active when the eyes are wide open, and if I close, if eyes are closed, it shows one is drowsy. Sorry.
And the future enhancement in our model is like we have implemented in only a software thing. We can use a Raspberry Pi and embed dump all this code in a that Raspberry Pi board, and using a Raspberry Pi camera, and we can give an real-time detection. And we can also give an audio output, like whether what's the distracted thing in a driver, like whether it's a safe driving or texting left, texting right. For demo purpose, we are using only a text to display on the camera. Thank you.